Hello, welcome back to Cracking the Cryptic, and loads going on the channel at the moment. So yesterday, thank you if you watched the streaming of Barbar Is You, a new chapter in that. Simon and myself had some hits and some misses, but people were very tolerant in general from when I was watching the chat. Thank you for that. And in the messages afterwards, the video is available on the channel now. Along with, of course, both our regular Sudoku videos from yesterday. Now, also on Patreon, extra content yesterday. Simon has posted Bataku's puzzle Euclidean Geometry or Euclidean Lines. I can't remember quite what it's called, but he's also posted a solution video to that as well. And there are just 3 days left to go in our padlocked lockout lines Sudoku pack. Now, I also posted some gas puzzles in my video yesterday. They are available on the Discord channel. If you want them more up to date than I'm solving them, do go to the Discord channel, where you will also apparently get the benefit of Clover, Philip Neumann and Sam Cappleman-Lynes' banter on the channel as well. I don't see that because I don't want to spoiler anything that I'm going to be coming up against in that series of puzzles. So that's why I'm not reporting on that in the channel, but it's all available there. So we've still got our apps available, still wrestling a bit with Google Play about a couple of them. Thank you so much to everybody who's written with advice and help and tried to do things. We didn't know we had so many viewers who work for Google. That's incredible. Thank you for all your help. And of course the SUDOKU PAD app, which has no such problems, and also the merchandise, all available. So do check into that stuff. It's all on the links below the video. The first link, however, is to this puzzle. And I don't normally get to do a puzzle by Jovial. It's normally Simon, so I'm looking forward to this. It's called 8 Squares, and that's because it's a killer Sudoku, I think, and the only clues we have are 8 little 2x2 killer cages. So the rules are normal Sudoku rules, and within each cage, digits can't repeat, and they add up to the number given. So these 4 digits will add up to 25, and they could include a repeated digit. So that's what we've got. Do give it a try on the first link, as I say. I'm going to start now. Jovial's puzzles always have something interesting. I'm sure it'll be worth your time, but I'm going to start now. Let's get cracking. So, well, we get a 10 cage very generously in the bottom corner. So that must consist of 1, 2, 3, and 4. The only 4 different digits that can add up to 10. Now, an 11 cage has to be 1, 2, 3, and 5. So the 1 digit in this box has to be a 5, because it can't be 1, 2, 3, or 4 anymore. So we're away. Thanks, Jovial. This 11 cage is also 1, 2, 3, and 5, but the 5 now can't be in row 7, where we find instead a 1, 2, 3 triple. But I don't know how to use that yet. These digits, I'm mad for pencil marking, as you know. They are 6, 7, 8, and 9, because the other digits have been used in the cages. The 29 cage, that must be 9, 8, 7, and 5. It's the only combination of 4 digits that adds up to 29. This 28 cage must have a 9 and an 8 in it, I believe. It's either 9, 8, 7, 4 or 9, 8, 6, 5. But I don't know which, and I don't know how to tell. And these other numbers, 25, 23, and 17, are a lot less useful. They're not 10s and 11s and 29s at all. Okay, so I need to do some thinking now, as if I haven't before. What can we do here? 17 cage doesn't have to have a 1 in it. It could easily be 2, 3, 4, 7 or 2, 3, 5, 6, both of which would fix that as a 1. So does it have to have 2 numbers in it below 4? I think that might be more definitely true. If it didn't, it would have 4. No, it doesn't. 4, 5, 6, 2 wouldn't fix this cell. Okay. Now we said this one is 9874 or 9865. Right. So this is about virtual X-wings, perhaps. I'm not sure yet. But it's about how many repeated digits. Yes, I was asking how many below 4 go in this. The question is how many below 5. Now, there must be 2 digits below 5. I think. You couldn't have 5, 6, 7 and 1 small digit because you'd already be over 17. So 2 of the digits must be below 5. And those same 2 digits are in this box as well. And that's going to use up whatever those 2 digits are for column 1 and column 2. And in column 3, they can't be in boxes 4 and 7. They're both going to have to be here. But we can only have a maximum of 1 digit in this cage below 5, which could be a 4. And the other one will have to be here. That has to be right, I think. There are 2 low digits, by which I'm talking about digits under 5. I'm just recapping now. 2 low digits in here. Obviously, those 2 low digits appear here. Those 2 low digits must appear in those 3 cells. One of them can be a 4 in this cage, which is therefore a 9874 cage. And the other one is here and is 1, 2, or 3. And therefore there is a repeated 4 in this cage. And one other low digit which also appears there. It's 17. So the other 2 digits have to be higher. So does that mean it's either 4562 or 4571? Wow, so there's definitely a 5, and then either 62 or 71, but not a 3, so that's not a 3, that's the 2 or the 1. There's no 4 here. So this is 4562 or 4571. Wow, that's strange. Okay, so we've got the 4 repeated, 4 repeated, 4. 1 or 2 repeated, 1 or 2 repeated, 1 or 2. Oh, look, there's no 6 in this cage, so that 6 says there's a 6 in one of these 2 cells. So we can take 6 out as possibilities there. I don't know what here. Can't be 5 or 4. No, not very interesting. There's no chance. I suppose with the same trick might be applying over here. Yes, I think it might. Oh, this is hard. Okay, let me work out. Let's look at the 4 big digits over 5 then. 6, 7, 8, and 9. Now, if you tried to keep 3 of them out of this cage, you'd need 5 plus 4 plus 3 is only 12 plus an 11. That's not going to work. So 2 of the big digits. Oh, 5 is included. It's slightly different from over here. Right, digits over 4. Obviously you must have 2 of them. And therefore, they're not necessarily going to repeat, because you could have a 6 here and one of these digits. Could you then have 2 digits under 5? It would have to be 3, 4, 9, 8. That's not going to work, because that would repeat 9, 8 in columns 8 and 9, and you can't fit 9 and 8 into those 3 cells. So there are 3 digits more than 4 in this box. I think that's what I worked out, but I'm getting a bit confused now. You can't have 3, 4. I think I did the maths wrong actually. 3, 4 is 7 plus 16. 3, 4, 7, 9. Because that would repeat 9 and 7. That's what it is. And they couldn't fit in those 3 cells. Okay, so the principle's right. My maths was wrong. And any numbers below that, you're either going to repeat 9 and 7 or 9 and 8. So So this has to have 3 numbers over 4. One of them can be a 5, because that can repeat there and in the cage. One of them can repeat here, and the other is going to have to be 6. So this is going to have to contain 5 and 6, and another 12, one number over 3, and one number under 3. I think that's right. Or should I be talking about over 4? Could this be 4, 5, 6, 8? Yes, it could. Then you'd have 5 repeating there and an 8 there. Or it could be 3, 5, 6, 9 with the 9 here and the 5 again here. This is always a 5, right? So 5 and 6 are definite, either with 3, 9 or 4, 8. So we get 5 here. This is the repeated 8 or 9, which must happen. Wow, I'm sorry, I probably shouldn't be struggling with the arithmetic quite this badly, but anyway, we're getting there now. And what else is that telling me? It gives me that 5. 1, 2, 3 set. Yeah, this is either 3, 5, 6, 9, and that's a 9, or it's 4, 5, 6, 8, and that's an 8. Okay, that's right. There's definitely a 6 there. Can I use this 25 cage? That's a hideously averagey number. I'm not sure how to use it. Okay, I need to think about this a bit more clearly. We've got a 6 and a 5 in those cells. So these others are from 1, 2, 3, 4, 7, 8, 9. That's not very interesting, is it? There's definitely a 5 there. There's definitely a 5 in that box, in that cage. There's definitely a 5 in one of these 3 cells. 5 here, 5 here. I don't really know what I'm meant to be thinking about at this point. Okay, struggling a bit. Right, let's have a think. One of these numbers is low, is 1 or 2. We've got 4, 5, and either 1 or 7 or 2 or 6. But 1 or 2 must also be, or 1, 2 or 3 rather, must be in one of those cells, because in column 3 we've only got 2 cells so far that need a 1, 2 or 3. So there's a virtual 1, 2, 3 triple in the box from there, 1 in there, and 1 in there. So these aren't from 1, 2 or 3. Doesn't feel all that useful, I have to admit. Okay, let's fill it in because I've worked it out. 4, 5, 6, 7, 8, or 9 go in those cells. So one of these can be from 1 or 2, from 1, 2, 3 rather, and 2 of those oh, these can't be 4 or 5 because they're in that box. Okay, they're getting a bit more limited now. They're from 6, 7, 8, or 9, and that's a quadruple. That's something. So these can't have 6 or 7, and now 6 isn't available in this box. Wow, so it is 7, 5, 4, 1. Is my maths right there? Yes, 17. Okay, that's 7, 5, 4, 1. So that's not a 1. They don't have a 7. We've got a 7 there. We can't, oh yeah, we could repeat a 7 here, that's fine, okay. We haven't made the 1, 2, 3 triple. I think this has to be a 1 though. Yes, we've got a 1 in there and a 1 in there. That's the thing. So that's a 1. One of these is 2 or 3. 6, 7, 8, 9, triple. So this is 2, 3, or 5. Can't be a 4 because there's a 4 in the cage. These are from 2, 3, 5, 6. Okay, there's something quite interesting there in that there must be a septuple because the only places for 8 and 9 are in those. So that can't be a 6, and this can't be a 7 because one of those is a 7. Yeah, that's true. Wow. I'm very gradually picking my way through this. I have a feeling this ought to be a bit easier than I'm finding it, but intriguing puzzle. At least one of those is 6 or 7. It doesn't tell me anything there. I'd love to know which of those two was a 6, because that would be significant, especially if there wasn't a 6 there. 4 I need to place in the top row somewhere. Oh, there's definitely a 1 here now. That's slightly interesting. That rules 1 out of all of these cells. And actually this can't be a 1 because the other ones in this cage would have to be 7, 8 and 9. And this cell can't be 7, 8 or a 9 because of those. So that confines 1 to those 3, which isn't enormous in terms of information. But it does mean this 25 cage is doing some work at last. Not really heavy lifting. This 1, 2, 3 triple, I haven't used that at all. Again, 4 is getting confined in various rows. But that may be the extent of what I've got on 4. Oh, look, 1 and 2 in this final column can only be in those 2 cells. That's quite analogous to that 8-9 pair. And I hadn't seen that. That's another 1, 2, 3 triple, so they can't have a 1 in. So one of these is definitely a 1. Actually, I can take out most of the pencil marks. One of those is a 1. Most of the corner marks. One of those is a 7. 4 and 5 are spread around willy-nilly at the moment. But there's a 1 in one of those. Now, this can't be a 1 either, for the same reason that that would still have to be 7, 8 or 9. So that's not a 1. And this is not a 1 now because of 1 appearing in those cells. So the 1 in this row is definitely in one of these 3, but that's a 1, 2, 3 triple. So it's not in either of those. That is a 1. So that's a 2. That's not a 2. I mean, this is very gradual again. Oh no, it places 1 in this cage. Down here. Oops, here. 1 there. Right, that places 1 in this cage. So there's a 1 in one of those 2 cells. Oh, I was going to rule it out of that, but actually I don't think I can because 9, 8, 7 could go in those 3. It's this cell it can't go in. So one of those 2 is a 1. Oh, that can't be a 1 again for the same reason it would put 9, 8 or 7 there. Oh, and those 2 can't be a 1 because of 1 there. So actually this is a 1. That's the only place in box 5 for it. And that's going to fix our other ones. There's a 1. There's a 1. Oh, and there is now a 1 in the 25 cage. That's pretty. Right. The other 3 are 9, 8 and 7 to make the 25 total work. And suddenly that's helpful. There's a 6, 7, 8, 9 triple, quadruple, which actually is a 7, 8, 9 triple and a 6. So now I do know where the 6 goes. These can't have 8 or 9 in. Or 6. 2 has to go in one of these cells. What have we got? Oh, I don't know. This is this is a 5 and a 6. So 6 is now not in those cells. Let's take out, well, 6 is now definitely in one of these. This must be 3 or 4 and 5. This must be 6 and 8 or 9. So that's really reduced the possibilities there quite considerably. I'm probably missing something. Those can't be 1. There's definitely a 1 here and a 1 here. In fact, those are the remaining ones we have to place in a little X-wing. 2 and 3 have to be in those cells. Oh, 7, 8, 9 triple. Not very useful. 8, 7, 9 there. One of those is a 7 for this row, so that's not a 7 for the cage. Five, 7, 8, 9, 1, 2. So these other cells are 3, 4, and 6. That top one can't be a 6. We've got the same triple over here, a 7, 8, 9 triple in box 6. We've got one of them there. One of them must be in one of those two cells. And one of them must be in these two, because to get 7, 8, and 9 in this column needs one in those. Right, this sees a 2, 3 pair, a 1. 5 and 6 are in the cage. So that's 4, 7, 8, or 9. That's not quite the sort of thing I need. 2, 3, 5, 1. We've got 4, 6, 7, 8, and 9 still to fill in this box. Oh, that's quite interesting. I've suddenly discovered where 3 is in the final column. Can't be in those cells. And these ones aren't admitting it anymore. So it's here. And now we know that this cage is made up of 3, 5, 6, and 9. Just checking the maths again. Yeah, okay. So a 6, 9 pair. We can place 6 in row 6. In fact, it's in row 6 and column 6 there. We've got a 6 down here. 5, 3, 6, 9. Those can't be 9s. 2 has to be here. It can't be here because of that 2, 3. So that one is from 4, 7, or 8. That 2 fixes the 3, 2 pair. I have a feeling I could have fixed the 3 pair on what I found earlier. That 3 is fixing things in the whole column. 4, 9 there. That's now a 4 because there's a 7, 8 pair in the box. That's doing sterling work in this box, leaving us with a 1, 4 pair, I reckon. 1, 4 there, 2, 6, 9 there. That is 3 or 8. These are from 3, 5, 7, 8. Oh, look, in this row, 6, 1, 5, 3, and a 7, 8, 9 triple. So we've got 2 and 4. And wrong mode. We know which way round because of the 1, 4 pair here. Right, now we are on track. 8 there, 9. 8 in column 1. That can't be 8, and these two can't be 8, and these two can't be 8. This has become an 8. That's a 7. That's an 8. That's a 9. This one's a 3. That one is a 9. 3, 5, 7 triple across the middle. That can't, those both can't be 9s, and that can't be a 3. Sorry, this is probably the long way round the houses, but I may be missing something that's very clear to you. 9 there. 9, 1, 3, 2. None of those are a 6. The 6 in the row has to be here. Yes, sorry, that was fairly clear. And I was still not spotting it. One of these is a 5. Oh, that's not a 5. It's not fixed though. 6, 9, 7, 8. One of those, yeah, I just said one of those was 5 and concluded it again a different way. One of those is a 4. Oh, 9. 9, 9, that has to be a 9, and that place is the 6, which makes that a 7. This is a 6, that's a 9. Oh, that looks quite helpful. 7, 8 pair. We can finish the other cells in the cage with a 4 and a 9. 5, 6, 7. Don't really know about this 1, 2, 3, 4 set. It's quite puzzling to me that this still solves from here. That's a 4, 7 naked pair. They see every other number in the row or cage. 7, 9, 6. So this is a 6. Okay, that's good. That finishes box 6. They can't have a 9 in now. Got 7 there and an 8 4 pair. They can't have a 4. These are from 2, 3 and 5. These are from 2, 3 and 8. Well, that can't be an 8. In fact, 8 in the box must be there. It's so weird that this is still resisting. Or maybe I'm just being not comme il faut. Let's get a 2 there. Right, 3, 5, 2 triple sorted out in box 1. That gives us the 5 in this cage. 8 there. 7 and 9, yes, they can be done. Then we get 7 here. 3. 5 and 8 are resolved. And the top 3 boxes are all done. We must be on the home stretch by now. 5 there, 7, 4, 7, 3, 3, 5, 2, 1, 3, 4, 2, and 1 pair left to resolve. What a neat puzzle. That's really good stuff. It's a very skilled creation of a killer Sudoku there. Really interesting solve. Thank you so much to Jovial. I hope you enjoyed that. Hope to see you again soon on the channel. Bye for now.